We are literally standing at the edge of a fundamental revolution in robotics. So forget what you think you know, because today we're talking about the dawn of physical AI. For decades, we've had this image of robots, right? Kind of clunky, pre-programmed, and if one tiny thing went wrong, the whole operation just fell apart. Well, that whole idea, it's pretty much out the window. So the big question is, why are robots that act like machines suddenly a thing of the past? And the answer? Well, it's actually pretty simple, but it's also incredibly profound. It's all because of a brand new kind of AI, one that allows them to stop just following lines of code and start to reason, to adapt, and to react just like living organisms. This is the core shift we're going to break down. All right, so let's dig into this. What does it actually mean to go from a machine to an organism? This is the fundamental shift right here. Let's just put it side by side. On one hand, you have the classic machine. It follows super strict rules. And you know what happens, right? If anything unexpected occurs, someone bumps it, an object isn't where it should be, game over. The whole system just fails. But then you have the organism. It's totally different. It adapts to its messy environment. It actually learns when things go wrong. Okay, so to really get how big of a deal this is, we gotta look at what was holding robots back for so long. Let's pop the hood on the old robot brain and see why this committee approach was such a disaster. The problem, and this was a huge one, was that a traditional robot's brain was totally disconnected. Think about it. You had one system just for seeing, a completely separate AI for thinking and making decisions, and then another system for actually moving its arms. And these different parts, they were terrible at talking to each other in real time. It was literally like a committee meeting where everyone's speaking a different language, which led to all those delays and that classic clunky robot behavior we all know. So, yeah, that old approach was a mess. It clearly needed a new kind of mind. And that is exactly what we're seeing now with something called Vision Language Action Models. VLA models are the absolute game changer. Instead of that fractured committee, a VLA is one single unified AI. It takes in the raw pixels from its camera and text commands from a human, and it processes all of that together to create motor commands directly. No more middlemen, no more lost in translation moments. It really just boils down to this super simple but powerful formula. What the robot sees, plus what you tell it to do, equals direct physical action. It's that seamless. Vision and language go in, movement comes out, all in one go. Now here's where it gets really, really cool. The AI basically learns to treat robot movements, things like rotate wrist 5 degrees or close gripper gently, as if they were just words in a sentence. They call this action tokenization. It means the AI can string these physical actions together to form a coherent sentence of movement, just like you and I string words together to talk. It's like we've given the robot a language for interacting with the physical world. And when you have this new, unified mind, you get these incredible abilities that feel less like programming and more like instinct. Let's talk about how these robots now have something that looks a lot like a physical reflex. So because these models have basically read the entire internet and seen billions of images, they have this built-in physical common sense. Think about it. It hasn't just seen a million photos of a glass, it's also read descriptions about glass being fragile. So when it sees a glass, it just knows it's brittle and needs a gentle grip. It sees a sponge and gets that it's squishy. The robot is automatically adjusting what it does based on an understanding of the object's properties. And this fluid, almost biological reaction is possible because of a concept called harmonic reasoning. This is a massive, massive breakthrough. It means the robot is no longer doing this clunky think, then act thing. It's thinking and acting at the exact same time, in this perfect continuous loop. And that's what allows for those instant, real-time reactions we usually only see in living things. Let's make this super clear. Imagine you push an old-school robot while it's working. What happens? Its hard-coded safety rules kick in, and it just stops dead. It freezes or maybe even crashes. But do that to a physical AI with harmonic reasoning, it feels the push, understands it's a physical interruption, and in real time it adjusts its balance to stay upright and just keeps going. It's not a safety stop, it's a genuine physical reflex. So this is all just mind-blowing, right? But what's maybe even crazier is the speed at which all of this is improving. Let's get into the mechanics of why this revolution is accelerating so fast. They call it the intelligence flywheel. So researchers found these things called scaling laws for robotics. And what they discovered is that once an AI model gets big enough, we're talking around 6 to 7 billion parameters, which are kind of like the neurons in its brain, something magical happens. They call it a phase transition. Before it hits that threshold, the robot is just mimicking. It's just copying actions it's been shown over and over. But once it crosses that magic number, it starts generalizing. It can take what it learned about picking up a ball and apply that knowledge to picking up something totally new, like a fragile egg, without any new training. This is the huge leap from just copying to actually understanding. And that leads to this incredibly powerful self-improving loop. So, step 1, you put these smarter, generalizing robots out into the world. Step 2, they start collecting tons of real-world interaction data, 24/7. Step 3, you feed all that new data back into the main AI model. And what happens? The entire fleet of robots gets even more physically skilled. It's a flywheel that just keeps spinning faster and faster. And look, this whole intelligence flywheel thing isn't just a cool idea. It is happening right now, built on real hardware and real software. The dawn of physical AI, it's officially here. And this isn't science fiction, it's being powered by some seriously incredible tech. You've got specialized computer chips like NVIDIA's Jetson Thor, which is basically the robot's brain, letting it make all these split-second decisions on its own. And then you have platforms like NVIDIA Cosmos. Think of it as a virtual universe where these AIs can simulate literally millions of years of physical experience before they even touch a real-world object. So that brings us to the big takeaway here. We've gone from robots that are programmed to robots that truly learn. They're no longer limited by human code. They're only limited by their own continuous physical experience with the world. And that leaves us with this one kind of profound question to think about. When robots can learn from interacting with our world 24 hours a day, 7 days a week, what happens next?